The Port of Gladstone, one of 4 ports managed by the Gladstone Ports Corporation, is one of Australia's finest deep-water harbours and Queensland's largest multi-commodity port. The Port of Gladstone is a naturally turbid estuary driven by large tides, winds, waves and rainfall. Sediment movement and deposition is continuously occurring in the port, and to ensure safe passage for vessels, GPC must manage the sediment that accumulates within the shipping channels to maintain channel depth. To better understand our interaction with the environment, GPC has undertaken investigations into sediment behaviour around the port. Sediment found within most areas of the Port of Gladstone, particularly in the inner harbour, contains silts and clays, which are subject to the process of flocculation. What is flocculation? When in fresh water, clay and fine silt particles settle individually. This means the settling velocity, the speed at which the sediment settles, is very low, as can be seen in many Queensland ponds and dams that remain brown or turbid. These particles are of a negative charge and repel each other like magnets of the same charge. However, when clay and fine silt particles in suspension are in seawater, flocculation of the particles can occur. Flocculation is the process of fine-grained sediment sticking together as they collide through different speeds of settling and turbulence. This process occurs due to the positive ions in seawater attaching to the clay particles. The particles now have short-range attractive forces, allowing them to stick together and form aggregates known as flocks. Flocks are greater in size, weight and settling velocity than individual particles, thereby accelerating the overall settling process. When there is more fine-grained silt and clay present in suspension, there is more potential for flocculation. Accordingly, the flocks will be larger in comparison to less turbid water. The process of flocculation is important for increasing the settling potential of fine-grained sediment discharged by rivers into the sea during flood events. It also explains why flood plumes travel so far as they mix with seawater until the increase in salinity and reduction in turbulence allows flocculation and increased sedimentation. How does flocculation relate to dredging? Dredging results in an increase in particles in suspension close to the dredger when compared to natural suspended sediment. The coarser silt to fine sand particles quickly settle out of suspension, resulting in a plume of predominantly fine-grained silt and clay, which can be transported away from the dredger by tidal currents. As with natural suspended sediment, the fine-grained sediment suspended by dredging is predominantly present as flocks. However, dredging has the potential to break up larger flocks due to the turbulence from the dredging process, resulting in the flocks in the plume close to the dredger being smaller than flocks in natural suspended sediment. The process of flocculation continues to occur on these smaller flocks from dredging, and they soon become larger and indistinguishable from natural suspended sediment. This similarity demonstrates that dredged sediment in suspension will behave in the same way as the natural suspended sediment, which is being regularly resuspended and deposited. Investigations have found that resuspension from maintenance dredging and placement activities represents less than 1% of the total annual resuspension in the Port of Gladstone. Results from our investigations show that based on the typical sediment in suspension, both natural and as a result of dredging, particles will settle approximately 6 times faster due to the process of flocculation than they would in fresh water. Therefore, after a dredging campaign, water quality will return to normal levels within a few hours. This increased settling of the fine-grained sediment due to flocculation results in the majority of sediment remaining within the Port of Gladstone. For more information on Gladstone Ports Corporation, visit gpcl.com.au.